Okay, so we're starting with one-dimensional motion. So initially we have to go over the equation, which is, where's the v final, which is the final velocity of the object, squared, minus v squared initial is equal to 2 times the displacement times the acceleration. So basically when we are looking at one of the problems, the problem is a kangaroo is capable of jumping to a height of 2.62 meters. And we needed to find the takeoff speed of the kangaroo. So what ends up happening is the final velocity is going to be 0. Is going to be 0 because eventually the kangaroo stops accelerating upwards at the top of the jump. And then eventually, I guess we can do this, minus the square of its initial velocity, which is what we're trying to find, because it's the initial takeoff speed, is equal to 2 times the displacement, which is going to be 2.62 meters, because it climbed to a height of 2.62 meters, and then times the acceleration, which is minus 9.8, because that's the gravity. What? Which is also meters per second squared. And so when we solve for v squared initial, we eventually get v initial equal to 7.166 meters per second. Shut up, Miles. I know, but we can switch it. Here you go, Emma.
So then, part 2 of the problem asks what is the hang time of kangaroo. So for that, we're going to need to be able to figure out how much time is there. So we're going to use a different equation for this one. So the equation we're going to use to figure that out is the final velocity equals the initial velocity plus the acceleration times time. So we already talked about in the last one that the final velocity is 0 because when the kangaroo is at the top of its jump, it's not going to be at a speed. Like when you jump, you have that pause at the top. So that's why its final velocity is 0. So then we also know the initial velocity, and we know the initial velocity from the first part of the problem. So the initial velocity is 7.166 meters per second. And then we also know the acceleration, which is going to be negative 9.8 meters per second squared, because that's the acceleration that due to gravity, because gravity is going to be pulling it back downward. And then we're going to be multiplying that by time, and times what we're trying to find. So then if we just solve this equation, we end up getting, I just did this, .731 seconds is the time, which finishes up that problem.